I'm Kirk Harnack. On This Week in Radio Tech, Chris Tarr, Tom Ray, and Chris Tobin join me with our guest, Steve Lampen. On This Week in Radio Tech, next.
Netcasts you love.
From people you trust.
This is TWiRT.
Bandwidth for This Week in Radio Tech is brought to you by CacheFly at CACHEFLY.com.
This is This Week in Radio Tech, episode 111, recorded January 4th, 2012. Now that's a twisted pair. This Week in Radio Tech is brought to you by Omnia Audio and the hugely popular Omnia One processor. Get your 5-band upgrade today for free at OmniaAudio.com. Hello, it's time for This Week in Radio Tech. I'm Kirk Harnack, your host, and I thank you for joining us. Hey, if you know what the title is, you probably know what the show's about. We talk about radio technology, and sometimes we get a little far afield. We talk about ham radio, but normally we talk about broadcast radio and audio and transmission and all the things that make that happen. We've got a very interesting guest on this show, and I am really delighted. We'll be introducing him in just a moment. But first, let me introduce you to our regular co-hosts. They're all here. We have from Manhattan, the island, the city, the best-dressed engineer in radio. It is Chris Tobin. Hey, Chris, how are you?
Hello, Kirk. I'm doing fine. It's a little chilly here in the city this evening, but other than that, doing well. I'm just enjoying a nice, cool ale right here, Celebration Ale. As you see, because they're no longer stocking it. So I bought the last 6 cases at the store. Sierra Nevada. Right. Can't beat it.
That'll last them for an hour.
Thank you.
That's right. Also with us from Muckwonago, Wisconsin. Let's head out the Midwest real quick, where it ought to be really cold. It's Chris Tarr. Good to see you, Chris.
Thanks for having me, Kirk. I think it actually hasn't been too bad here. It's going to be in the 40s later this week. I'm the Director of Engineering for Intercom's radio stations in Madison and Milwaukee. I also host the site, The Virtual Engineer, at broadcastengineering.info, contributing writer to Radio Guide and all kinds of other stuff.
Well, good deal. And also with us from the Hudson Valley of New York, it is Tom Ray. Hello, Tom. Good to see you. Are you muted, Tom?
He sounds so much better.
He's a mime. He's a mime.
I hit the wrong button. And like I was saying before I was so rudely not interrupted, I chipped my way into the house tonight when I got home because it's so doggone cold up here.
Is that causing you guys any technical problems at WR or other Buckley stations?
No, not really. We're just doing fine, and you just hope that a power line doesn't snap. But I get more concerned, and we do have problems when there's some icing, and actually that's all you need is a piece of ice to come down and go through your tuning house roof, and that can ruin your whole day.
Yeah. Or ice mess up a guy wire and take down your whole tower.
Well, that too. I hate it when that happens.
Yeah. We've talked about hazards of winter broadcasting, but I guess the power going out is probably the chief one. Power's carried by wires, and does that give us a nice little intro to the next to our guest, the next guy I'm going to introduce, Mr. Steve Lampen. Works for the folks at Belden Wire and Cable. And I want to introduce Steve. And I want to tell you, Steve is a guy I've always wanted to talk to at length and never had the opportunity. So let's bring him in now. Steve Lampen from Belden. Hi, Steve. How are you?
I'm fine. Thanks for asking me.
You are in studio in Petaluma. So you're at
in Eggtown, California.
That's Eggtown, California. I've not heard it referred to that, but I'm sure you're from there. You know what you're talking about.
Well, I'm just a little south here in San Francisco.
Yeah. Well, tell us, your title there is Multimedia Technology Manager. What does that mean? And, well, first of all, why don't you tell us what Belden does, and then tell us what you do there.
All right. Well, both of those are kind of hard to answer. Most people know Belden as the world's largest manufacturer of audio and video cables. We actually make 6,000 different kinds of wiring cable, actually more than that now. And we cover the entire range of, if it carries a signal, we probably make it. We don't do things like high tension, high power lines and things like that, but if it carries a signal, it's something in our gathering. We're certainly the world's largest manufacturer of audio and video cable, which is probably why you invited me here today. And we've been doing this since 1902, since pretty much before there was audio and video. So a lot of the stuff that I'll be showing today are things that either we invented or we pioneered or stuff like that. So, and you can see we have absolutely no ego whatsoever. So, but,
well, I've certainly used a ton of Belden wire.
Yeah,
a
we've
couple
been
other
around
brands
for a while.
too. But man, yeah,
we're kind of hard to miss.
I know.
But along the way, now what's happened in the last few years? I mean, we got a new CEO, a guy named John Stroop, and his idea was to take all the money that we'd collected from you guys and start buying stuff. So we've been buying companies right and left, and not just other wire companies, although we have bought a bunch of those, but also things like we're making Ethernet switches now, and we have 2 companies that make Ethernet switches. We're making connectors. In fact, I have off to the side here some BNCs. We're now making BNCs, which we never made connectors in 100 years. Now suddenly we're making our own BNCs. Who knows where we're going to go next? In fact, I'll tell you, if any of the listeners have an idea of who we should be buying, and that's no joke, I am all ears. I will pass it on to our acquisition team. We actually have an acquisition team. Belden has 7,000 employees. I'm the only one that does what I'm doing, which nobody knows what I'm doing, so that's why, which is kind of wander around the world and schmooze with other engineers, as we're doing right here, right now. And which is why my title, Multimedia Technology Manager, means nothing at all. You know, I invented that title, and it gets me in the door because nobody knows what it means. But it sounds cool. And we talk about techno things like we're going to talk about.
Well, now, before this show started, we were chatting, and Tom Ray of there in New York was mentioning that you had been to the SBE chapter in New York and had them all
well. In fact, if there's an SBE chapter that would like to have me come speak, this is what I do for a living. So I'm actually headed for St. Louis later this month. If you want to come to Chapter 55 and listen to me speak, I'll do it there. And I'm speaking at NAB. I'm speaking at HBA. Last year, I attended 103 trade shows, a new record for me, and spoke at 70 of them, something like that. So I have very good vocal cords.
Gee, and a lot of airline miles, I suppose, too.
And I'm a 1K on United. Yeah.
So you know, wire, we so often, as engineers, we take for granted. We know we have to hook things up right, but we often take the wire itself for granted, or maybe the technology that went into the wire, while we spool off foot after foot, yard after yard, meter after meter of this stuff that is absolutely critical to carrying the product that we're making or we're helping our talent to make. I mean, they're at the TWiRT network. They've got plenty of wire and cable. They've got a lot less wire than they would have if they weren't using, you know, so much Cat5 and doing things over Ethernet.
Yeah.
But they've got a ton of wire and cable there, and all broadcast facilities have a ton of wire and cable. So this wire that we use is absolutely critical. And so you're going to go into to telling us about, you know, what are some of the best practices for handling different wire types in a broadcast facility. Our audience is mostly broadcast engineers and those interested in radio engineering and audio engineering. And, of course, we have a huge part of the audience is also very much into Ethernet technology. So I don't even know where to start asking. Maybe you know where to start talking.
Yeah, I'll tell you. This is also a background I came from. I'm an ex-broadcast engineer, ex-radio guy, and was chief engineer at a bunch of radio stations back when I had a real job. Now I no longer do, but that's okay. And so I do understand what it's like to install a station and to get it to work. And I'm kind of in the cat seat now where I can actually see what's coming down the pike in terms of technology. And the one thing that doesn't scare me at all is Cat 5 or 5E or 6 or 6A, augmented Cat 6. In fact, I have right in front of me some Cat 6A, 10 gig cable. I don't know if we can switch to the overhead to show this, Cat 6A. And the thing is, this is 10 gig cable, 10 gigabits per second. And a lot of people will say, well, gee whiz, I'm in radio, I won't use that. And I'll say, ha, ha, ha. Well, you wait and see, because, you know, if you build a 50-lane highway, it'll be filled tomorrow if it's in the right place. So this is the 50-lane highway of wiring cable. And this is not the end either. I just was on a phone call yesterday talking about 40 gig. That's the next step. And there's another step beyond that that's already in planning, 100 gig. So lest you think that the networking of tomorrow doesn't apply to you, boy, you could not be more wrong, that this is, in fact, where it's all going to go. And this is, in fact, this isn't even our latest. This is an ancient version of 10 gig. This is our first version of 10 gig. We're a version beyond that now and working on even newer versions, of course. So
our co-host here, let's see, Tom Ray was one of the first stations in the country to build a facility that had all audio over IP.
Yep.
Especially one of the first, if not the first, multi-studio facility to do that.
Yep.
And then Chris Tobin came along and did something similar at CBS Radio with WINS. And Chris Tarr is getting ready to rebuild his facilities and put a lot of audio over IP. So it makes sense that we would talk about best practices for dealing with cat cable, and you know, what kind of things you see people doing wrong that you know ends up messing up the otherwise hard work that they've put into a facility.
Well, that's funny you should mention that, because when people started in broadcasting to realize that Ethernet was an option for them, that they could actually wire up using Ethernet, the thing that shouldn't have surprised me was the fact that some of the early installations I saw were some of the worst data installations ever. And it's clearly because broadcasters are not networking guys, and they never took a networking class. So I would say, if this is something that interests you, or this is a direction you're going to be headed, or you realize this is the call of the future, I'd say the first thing that you need to do is go take a networking class, learn about Cat 5 and 5e and 6, and how to put it in, and what the limitations are, and all those kinds of things that networking people already do. And the interesting thing is, wire is wire is wire. So that the things that you've learned about coax or twisted pairs for audio, whether it's balanced lines or common mode rejection or return loss, or all these things that might apply to certain kinds of cables that you would use, all apply to a networking cable. It's all the same stuff. That the twisted pairs on networking cable are, in fact, the best pairs we've ever done. So you could take advantage of the stuff that we've done for networking for where you're going to go. And if you're going to put in Ethernet, then clearly you need to learn more about Ethernet. That sounds kind of simple in a way.
Let me ask one of the first real basic questions here, and then I want my colleagues to jump in whenever they just feel like it. But I've always, people have asked me, why the twist in the wire? What's important about the twist? And I sure have noticed that a piece of Cat 5 or Cat 5e or Cat 6 cable, the 4 different pairs have different amounts of twist per given length.
Absolutely.
So maybe you can tell us about that, and then we'll get on into these best practices that we were chatting about.
Sure. In fact, I'll tell you a little story about twists of wires, so you'll see what the importance is. Back when category cables just began, when they began to realize that twisted pairs would make pretty decent data cables. Before then, it was all on coax. You might remember ThickNet, ThinNet, ArcNet. Those are all coaxes used for data. When they finally started using twisted pairs, and this was something IBM finally put in the market, they started making high-quality twisted pairs. That's when people said, wow, what we could do is take these twisted pairs and use data on them. That was pretty slow-speed data at the time. Now, of course, we're up to gigabits of data. And so the twisting of the pairs, the consistency, the symmetry of the pair is really quite critical, and to the point where you have 4 pairs that can't talk to each other. The whole point is to reduce the crosstalk between the 4 pairs in the cable. But now there's a second half to this. Not only, by the time you get to 10 gig, not only do you have a divider in the cable, which is dividing the 4 pairs apart. I mean, here in our original version, here's actually the divider and the 4 pairs that go around it. That divider is to keep the 4 pairs apart to get to the kind of crosstalk numbers you need. You also have this funny plastic thing here, which you can see on the outside of the cable. It makes the world's ugliest cable. And what that is to push the other cables away from it so that you don't get what's called alien crosstalk. And when you get to these high frequencies, this is 500 megahertz per pair, you begin to have pairs talk to their identical pairs in the next cable. That's a real problem. So the whole point is you need to push the cables away. Some people have a solution. They simply shield the whole cable. And that's a system that works. The problem is that shielding has its own whole line of problems that you have to deal with in the process of putting a cable like that in. And this particular cable is unshielded still, and yet it pushes the cables away so that you have low crosstalk between the pairs and yet low crosstalk between the cables, alien crosstalk. But let me tell you the story. I haven't even gotten to the story yet about twisted pairs. Back in the dawn of twisted pairs, Category 3, that was the first cable that was actually made to be data cable. And the powers that be, EIA, TIA, two groups that got together to make the standard, they said everything out there that's installed that's twisted pairs, we'll call that Category 1, and anything out there that carries data, we'll call that Category 2. But the first one they actually designed was Category 3. And so a different company, AT&T, gigantic company, much bigger than we are, decided that they would decide what the 4 twists of those pairs were. Now, the way that everybody did 4 twists in those days, they would twist the pairs and measure them, and twist the pairs and measure them, and twist the pairs and measure them, until they finally got 4 numbers where they wouldn't get very much crosstalk, and they would use those in the cable. Fine. But AT&T said, no, that's too, stone knives and bearskins. We're going to go fancy here. And so what they did was they literally hired time on a Cray computer to generate these 4 numbers. Now, this cable, Category 3, only goes up to 16 megahertz. It's not huge bandwidth or anything. But they went to Cray and said, okay, here are the parameters that we want. Tell us what 4 numbers they are. It took them $10 million and 2 weeks of 24-hour performance on a Cray computer to generate these 4 numbers. And no sooner did they generate those 4 numbers for Category 3, then suddenly they had Category 4, which was 20 megahertz. Well, those Category 3 numbers don't work anymore. You need Category 4 numbers. And no sooner did you have Category 4, then you had Category 5, which was 100 megahertz. And they realized very soon that there was no computer on Earth, and there still is no computer on Earth with enough computing power at 100 megahertz to put the numbers in and tell you what the 4 pairs are supposed to be. And now we're up to 500 megahertz per pair. 500 megahertz. So I guarantee you there's no computer anywhere, unless it's on some other planet, Tralfamador, that will tell you what the 4 twists are going to be. So how do we get these twists? We twist them and we measure them. And we twist them and we measure them. We twist them and we measure them. And when we're finally, sick and tired of twisting and measuring, we stop and we look at the data of what we've done over the last 6 months or a year to get those 4 numbers. And so the point is, it's not a specific number. It's the best numbers we've done over a period of time. And I'll tell you, one of the secrets that we have at Belden, well, there are really a couple of secrets, but one of them is that we have a super precise way of measuring the twists that we already did. Because, of course, the point is you're going to have to go back after 6 months and reproduce all these twists again. And so you have to measure them so accurately. We have what I would call a twistometer, which I have never seen. I am, one of 7,000 employees, but I've never seen this twistometer. And what this does is super precisely measure the twist ratios, what we call the lay length of the twists in each of our cables. So we can go back and reproduce them. One other thing that I should mention, just to throw a little ad in here, is one of the ways you can get super precise twists is by putting the 2 wires together, sticking the 2 wires together in each of the pairs. This is something we do. We call them bonded pairs, and we'd actually extrude the wires and stick them together at the same time. And I can't show this to you in a factory. You're welcome to come take a tour of a factory, but the one part we will never show you is our bonded pair part, because that's all got trade secrets and patents and stuff in there. You can go look up the patents, but the trade secrets you can't look up. And
Steve,
this is something we own and we still have a patent on, is bonded pairs. So we make these cables unbonded and bonded, depending on which you want, and of course bonded is dramatically better in terms of performance.
Steve, one of the things you had told us about when you came out to SB 15,
yes,
with the cable and the twist and such, allowing the faster data rate, a lot of the audio over IP systems that are in place, our Axia system at WR, for example, uses Cat5 or Cat6 as inputs. So
absolutely. And you're at 100 megahertz. You're 100 base T. It's pretty standard Ethernet stuff.
Yeah. What kind of noise figures and what kind of isolation do you get if you throw a microphone on it?
Well, that's very interesting because one of the things, these cables aren't tested below a megahertz. So if you're talking about audio running on these pairs, that was a giant question mark for a long time. And so what I actually did was I went to our factory and had them test these cables for crosstalk, pair-to-pair crosstalk, because these are unshielded pairs running low-frequency signals, low-frequency meaning audio signals. And the amazing thing is when you get to something like Media Twist, this flat stuff, which I know is one of the cables that you use, this flat 4-pair, this is a category 6 kind of cable, we could not measure the crosstalk at audio frequencies from pair to pair on this cable. It's unmeasurable. And the problem is it's below the test, it's below the level that you could test on a network analyzer, $60,000 Agilent Hewlett-Packard network analyzer. And the noise floor there is like minus 110. So somewhere below 110 dB pair-to-pair is the crosstalk of this kind of cable running analog audio frequencies. And I'll tell you, just because of this whole idea of running audio on a data cable, first of all, a lot of people said that's sacrilege. This is a data cable that's only intended for data. I can't possibly run audio on it. Well, that's ridiculous. Pairs are pairs. These are good pairs. You can use them just like you can any other pair. The only thing is they're not shielded. So the only thing you're concerned about is crosstalk between the pairs. Well, as I just said, we can't even measure the crosstalk. So clearly that's not a problem. And the kind of thing this has spawned, I'll show you a device we don't make. Here's something Belden doesn't make. We can go to the overhead. This is something called an InstaSnake. This is made by a company called ETS out of Fremont, California. And I don't know if you can see this, but it's got 4 XLRs here, and there's a 5th XLR in the middle, except you look really closely, that's not an XLR. That's an RJ45. In fact, it's one of those Neutrik speak-on connectors. And what it does is take the 4 pairs of the data cable, connect them to the 4 XLRs here, and bring them out through that RJ45 in the middle. And the interesting thing is if you use unshielded twisted pairs, it works great. If you need phantom powering, then you need a shield connection. This is actually a shielded Neutrik Ethercon connector here. If you put in shielded Cat 5 or 6, then you will get phantom power as well. The interesting thing is these people made these and sold, one a month or something until suddenly we had a certain president named Obama. You heard this guy? And at his inauguration, they had hundreds and hundreds of these boxes. In fact, they were told, the people at ETS were told, if it wasn't for the InstaSnake, the audio of the inauguration would not have taken place. That this was where all the audio came from, all over the place. All on Cat 5. Audio on Cat 5. So, this is what's happening. Cool stuff.
Audio on Cat 5, I actually have been doing that for quite a while and never thought that there would be a problem with it. I'm glad I was justified and vindicated that there isn't a problem with doing that. Yeah. What about, we do get asked about, what about AES audio and its impedance desires over Cat cable?
Very good question. Because this cable, the category 5 and 6 and things like that are 100 ohms, where AES needs 110 ohms. This is when I wish I had a blackboard, you see, because what I could do is simply do the math for you of what the return loss, what the reflection would be because of this impedance mismatch, 100 to 110 ohms. And it also depends on how good the cable is, because this Cat 5 and Cat 6 is made to a spec, and it can go as low as 85 ohms and as high as 115 ohms, for instance, and still be within spec. And the point is, by the time you look at this and you look at the AES spec, this is so close to the AES spec. AES allows 88 to 110, 88 to 132 ohms is the AES spec. That's almost exactly what Cat 5 and Cat 6 already are. So in fact, this is an even better choice for running digital audio than it was for running analog. It's even a closer match to running digital. So no problem there at all. And I'll tell you, that's one thing I didn't pull out of my little bag. I have a bag here with 100 samples. One of the things that we brought out, which now that I have 2 titles actually. The second title, which isn't up there, is Product Line Manager. I'm the product line manager, which means I think up all the new products. And one of the new products I thought up, which I'm looking to see if I can pull out, I'll pull out in a minute, is one pair Cat 5. Now, this is something all you guys would understand completely. Because if you're going to do audio, you want to go from one place to one place and end to end. But I showed this to all my data guys at Belden. They say, you are insane. Who's going to buy a one-pair Cat 5 cable? Doesn't make any sense. Well, guess what? We can't make it fast enough. Because it's for all those people who are doing non-data things on Cat 5. And there are lots and lots. It's not just you audio and video guys. There's all sorts of industrial stuff and things like that they need a one-pair Cat 5.
Makes a great phone cord, doesn't it?
Exactly. And it's the world's best mic cable if you don't need phantom power. Because it's a bonded pair, so it's the quietest mic cable ever made. And it's tiny.
Oh, it
I
is?
wish I could show it to you.
Oh.
It works really well.
Hey, actually, Chris Tobin had a question. I'm gonna jump in and interrupt him. Steve, would you talk for a moment about stranded versus solid wire?
Absolutely.
And when each is supposed to be used, and if they actually have different electrical characteristics aside from their physical characteristics?
Yeah. No question. The interesting thing, certainly in the data world, the reason they have stranded cables is to add flexibility to the cable. You're going to have a patch cord or something like that. But if you think about this, the impedance of a pair, which is really what we're talking about. You know, this is a 100-ohm data cable or a 110-ohm AES cable or, so on. Even 75-ohm video cable. They're all impedances. The impedance in a twisted pair is the distance between the two wires with the size of the wires as part of it, the resistance of the wires, RLC. Those are the three components of impedance. And so it's the distance between the two wires, the stuff that's on top of the wires, the plastic on the wires, and the size of the wire. Now, if you have a stranded wire in there, and you think about this, what's the distance between one stranded wire and another stranded wire? Well, it's kind of hard to measure because that stranded wire is changing its shape all the time. And so, therefore, the distance between them is kind of variable. Where if it's a solid wire, it's much more consistent in terms of its distance from one wire to the other. And so the point is, and this is true if you look up data cables and you look up the networking parameters of a data cable, the solid wire always outperforms the stranded wire. Always. And yet the stranded wire is probably twice as expensive as the solid wire simply because it's harder to make. You have to make the strands and put the strands together and put the jacket over that and that kind of stuff. So it's more expensive to make and not as good. And this is true of virtually every cable we make that we have both solid and stranded, is the stranded cables are worse in performance and twice as expensive. Whether it's stranded video cables, stranded audio cables, stranded data cables, stranding is complicated and expensive. And the only reason you want it is for flexibility or flex life. It's going to be in a factory and it's going to go back and forth for 1,000 times. You want it to last and not break. That's what flexibility is about, flex and flex life. It's not about performance. Did that answer your question?
Absolutely. Chris Tobin, I'm sorry I interrupted you. You were about to ask about wiring and best practices, and you have some experience in that in your former facility.
Yeah, oh yeah. Well, one of the arguments I used to get into with some folks was cable ties and category cable and bundles and pulling it tight so you can see the impression on the outside jacket. I talked to several folks, and you were at one of our SB New York City meetings, and you had told me the best thing to do is don't crush it, don't squeeze it because you'll just change the characteristics. How do you tell somebody this that's been doing cable pulls and working in studios, like you said, radio guys, maybe even TV? When it comes to networking practices, network cable practices, it's not something people gravitate to easily. How do what can I use to tell folks or explain to them? I've done measurements with some fluke testers, and you can actually see changes in the crosstalk settings and stuff. So I'm using testers, I could do it. But when you talk to someone, if you're at an SB meeting or maybe in your travels, how do you go about telling them don't do the cable tie very tight, or maybe use Velcro straps in place of that?
The only way, I think the best way, is I actually have a series of slides, which I'd be glad to give you, that show you what happens when you put wire ties on a cable And it doesn't have to be long. It's like a 100-foot cable with maybe 9 wire ties. And if you put less wire ties, actually, it can get worse because the wavelengths are then longer as opposed to shorter. And the whole point is, it's all about deforming what's inside the cable. If it's a twisted pair, you can squish that twisted pair so it's not the same impedance anymore. If it's a coax cable, you can squish the interior so it's not 75 ohms or whatever it's supposed to be. And the point is, so it's about deformation of the cable, and the less that deforms the cable, the better the performance is going to be. So if you can put like a Velcro tie, or even just a larger wire tie is better than a smaller wire tie. And if you can tie them by hand instead of using a wire tie gun, which is, that pulls it so tight, it's tighter than anything you could do with your hand. And so the point is, anything you do that reduces the amount of deformation of the cable will increase the performance of the cable. And then ultimately, the main killer is don't put the wire ties at a specific distance apart. And I'll be honest, you're absolutely right about one thing, is that I talk to a lot of old grizzled engineers, and I am one, so believe me, I take that personally. And to tell them, look, a beautiful installation will not work as well as a messy installation. And I hear groans and moans like you wouldn't believe. That in fact, when you randomize cables in a tray, that's the ultimate performance, because they will not interact with each other. You won't be tying them down. You won't be restricting them in any way. You won't deform them in any way. It just doesn't look very pretty. And so I tell people, look, how many people are going to open the rack and see your gorgeous installation job? Maybe once a year. Maybe the director of engineering will have somebody on a tour and say, look at this gorgeous installation job. Now compare the number of people who will actually see the inside of the rack to will actually listen to the programming or watch the pictures if this were video. And the whole point is, that ratio is probably like 1 billion to 1. I think the billion people who are out there listening or watching win. So they deserve the highest performance. And the highest performance is the least amount of effect on the cable.
So my messy
sense.
racks are for you, America.
Yeah.
Hey, Chris Tarr is about to embark on a big wiring project. And Chris knows all about cat wiring. I think he's got plenty of good technique. But when we're going to break a moment for a sponsor message. When we come back, I want to be sure we get from Steve information about, hey, putting the right RJ connectors on, and this thing called bend radius that I'm sure I've broken a rule or two there.
It's a guy named Ben Radius. You misunderstood.
Yeah, Ben Radius. But first, we're going to take a little break here and talk to you about one of our sponsors. And the sponsor for this show is happens to also be my employer, and I'm very grateful for their support of the show, and that's Omnia Audio. Well, here's something a little bit different. I'm not going to talk to you so much about a product, but about a little contest that we're having at Omnia. I was talking with our director of marketing for Omnia, and that is Denny Sanders. Denny is a programming legend in Ohio. He's in the Ohio Broadcasters Hall of Fame, and Denny and I work closely together. He's a great guy, and he understands what program directors and what engineers are looking for in audio processing. We were thinking about, we've seen a few random videos here and there that folks put on YouTube with their audio processing. And there's some Omnia ones, and there's some Orban ones, and some other processors too. We thought, wouldn't it be cool if we got some folks to shoot us a little video of them with their Omnia processor, preferably working in the rack, the meter's bouncing around. So if you love your Omnia processor, would you do something? Would you go make a little video of you and your Omnia processor and tell us something about it? Tell us about when you put it in, or how you adjusted it, or how you persuaded the program director that, yeah, this really is better, or maybe he persuaded himself. And just shoot a little video, shoot it with a little, mini cam or your phone camera, whatever it may be. If you want to put it on YouTube, great. If you wanted to send us the file, that would be fine too. If you want to send it to me, that's fine. We're asking you. Oh yeah, we're asking you to send them to D. Sanders. That's my partner, Denny Sanders at Omnia. D. Sanders at OmniaAudio.com. Or if you want to post it somewhere and just send him a link, that's fine too. But D. Sanders at OmniaAudio.com. We're going to take these submissions, all the decent ones. We're going to give you an Omnia AXE license, so you can process and stream your own station audio or your own project audio over the internet or privately, whichever you'd like to do. And we're also I'm going to see if we can talk Denny into giving something bigger away. Maybe we'll give away an Omnia One. Wouldn't that be cool? To give away a $3,500 audio processor. I wish I could promise you that, but I haven't secured permission for that just yet. But we certainly would like to see your video. Oh, there's an Omnia One right there on the screen. Oh, there's over 5,000 of those in service around the world now in just 3 years. What a popular box. Oh, by the way, if you have one of these and you have the 4-band version on FM processing, there's a free upgrade to the 5-band version. So you can go to the Omnia Audio website, omniaaudio.com, and look for software upgrades for the Omnia One, and you can download the new 5-band software. It's absolutely free. And if you buy one now, they're shipping with the 5-band software already in them. So shoot a video, let us see it. Doesn't have to be well edited. Just let us see you talking about your Omnia processor, and send that link to dsanders@omniaaudio.com. Please do that, and we're going to have a little fun with a contest, and hey, we're going to make you a big star, too. We like your video. Thanks again to Omnia Audio for sponsoring this episode of This Week in Radio Tech. All right, we're back at the show now. And Chris Tarr. Chris Tarr, I know you're a newbie here in this audio over IP business, so I'm sure you've got questions for Mr. Lampen, so you won't spend a lot of time installing things incorrectly.
Well, that I'm sure I'll still spend a lot of time installing things incorrectly. But, I'm going to try to avoid it. The big question is obviously with the plugs that go not only on Cat 5, Cat 6 cable, but on any type of connector. We all struggle with putting on connectors and finding the right types of connectors. What's a good is there a good rule of thumb to follow when when trying to find connectors for what you're trying to work on?
Yeah, I'd say the rule is the same rule that applies to everything: buyer beware. And if you think that it's a deal that's the most amazing deal you've ever seen, you clearly don't understand what it is you're buying. You get what you pay for. And I'll tell you, this is especially true in the data world, although it's just as true in the audio and video world. I mean, you probably know, I see XLRs all the time that are crap. I see XLRs that don't even lock with each other. It's like, where did these come from? Some factory in Fanghua, and they're cheap. Oh, yeah, they're cheap. But you want reliability? Oh, well, we forgot about that part, So that's going to cost another 10 cents for reliability. Well, it's the same thing in the data world as well, that you're going to put on a connector. And the point is, of course, there are connectors for each of the levels that we're talking about. Category 5, 5E, 6, 6A. Each of those has a connector and a jack that is that kind of performance. And if you take a Category 6 cable, for instance, and put a Category 5E connector on it, unless it's the world's most fantastic 5E connector, which I've never seen, but I guess it's possible, you'll only get Category 5E performance out of that cable. Because within that connector, just like within the cable, we talked about the crosstalk between the 4 pairs, it's just as critical inside that connector as well. And if you get the crosstalk performance that's 5E, which is not as good as 6, that's what you're going to get. And it doesn't matter what the cable's doing. You've ruined it at the ends of the cable. And believe me, this is true of every cable connector combination you can tell me. Whether it's a BNC or I guess an RCA might be an exception, but not by much. I mean, you can get good RCAs and crappy RCAs, and some of them fall off right away, and some of them actually hold on for a while, kind of thing. You're going to get the kind of performance that you've paid for. So that's why I'd say if you want to put in a connector, put in a network, if you want to put in Category 6A cable here and you put 5E connectors on it, don't expect more than 5E in terms of performance. But you could always go back and put Category 6 or 6A connectors on it and get the performance that was already in that cable. If that's what you have to do now, that's a perfectly viable way of doing it. Put in something for tomorrow.
Steve, I don't know that I've ever put a Category 6 connector on a cable, but I sure have looked at them, and I've noticed that there's an extra piece in there. It looks like a little piece of graphite or some kind of iron, something that the wires go through. What's different about a Category 6 RJ connector?
Well, theoretically, nothing.
Oh.
But, in fact, the problem is, and this goes back to the dawn of time when they first started Category 3, and which this cable was originally based on telephone cable. And so they had this brilliant idea back then that one of the things they would have to do is to make it backward compatible with the telephone. And because all these jacks, that RJ45 jack, that registered jack number 45, that was intended as a telephone connection. That's actually for T1. I mean, it's a fancy telephone connection, but it's still a telephone connection. And one of the things that it does, that it has inherent in it, is that the middle pair is the pair that carries the telephone. And the second pair, which might be a second line or power to the phone or various other things that it could have been, is split over that first pair. Which is why if you look at the wiring standards still to this day, and there are two, of which the winner, the big winner, is something called 568B, B as in boy, that's the winning standard. The second pair is split over the first pair. Now, back when you did Category 3 and 4 and 5, and even 5E, you would do the splitting of that pair and move one of the pairs around the other pair when you punched it down into the connector or whatever it required you to do to assemble it. By the time you get to Category 6, any dividing of those pairs, any moving apart of those pairs is so huge in impedance change that you would kill yourself. In fact, I have seen quite a few Cat 6 connectors, especially the male plugs, that by the time you put them on the cable, they just fail because you have split the pairs to put them on. And so what they do is inside the connectors, they're doing this splitting pair thing, which they have to do to meet the wiring standard. Now, you're going to say, why don't they go fix and change the wiring standard? Well, duh, why don't they? But that's the problem with a standard, is that the rest of the world is still wired up this way, and there's really no easy or simple way. Although by the time, if we ever actually had 10 gig stuff that you could do out in the field, it's probably unlikely it would be very much like the kind of connectors that you're putting on Cat 5 and 5E kind of thing. And that's one of the reasons why, I'll be honest and say, one of the things that Belden does not sell, and you cannot buy from us, is a plug. The very thing you want to put on the cable. What we'll sell you is a patch cord. This kind of thing. I have a patch cord here, just a little short one. We'll make this for you, a patch cord. Okay, here's a patch cord. And the point is, because of that, we can make it in the factory, we can test it, we can make sure it's working. This is 5E or something, which is no big deal. You could do this yourself. But by the time you get to 6, and by the time you get to 6A, which is 10 gig, forget it. Nobody can put that plug on. In fact, even in a factory, we have a harder time putting it on than anything else that we do. Which is why what we'll do is we'll sell you one of these. We'll sell you a jack. Here's a jack. And the whole point is, now, this is a 10 gig jack here. Here's a Cat 6 jack. And you can see the difference right away. Here's a Cat 6 jack, and you can see it has 2 rows of connections. 1, 2, 3, 4, 5, 6, 7, 8. Like that. You look at the 10 gig jack, and you suddenly realize, wow, this looks really different. Oh. Each of the pairs is at right angles. And again, this is to help prevent crosstalk from occurring between those 4 pairs. And believe me, this is only one of dozens of differences, and this is just the jack. This isn't even the plug. On the other side, you look inside the Cat 6, you probably can't see it here on very well. You have 6 little wires, or 8 little wires inside. You look inside this other jack, and what's inside here is compatible, but in fact it's a printed circuit board. It's a flexible circuit board with 8 little traces on it in the same places that the wires would have been, because these 8 little wires are simply not consistent, not symmetrical enough to work at these high frequencies at 500 megahertz per pair. So we literally had to build the jack from the ground up in order to get it to work. And so what you might want to say is, oh, well, I'm just not going to do Cat 6A. Well, that's like somebody saying, well, I'm just going to have a Model T. I'm not going to, 35 miles an hour for me is good enough. That'll get me anywhere I want to go. And it's like, obviously, if you had a Model T today, you might not make the minimum speed of the freeway. They might not let you on the freeway. So the question is, you want to get with tomorrow? You may not have much of a choice. And what I hear a lot of people saying is, I'll be retired by then. So good luck. If that's what you think the solution is.
May not be retired by then. And this is not learning electronics all over again. This is just a slightly different and improved way of.
That's the thing. RLC is the same stuff. Kirchhoff's laws still apply. Ohm's law still applies. There's nothing new. And it always gets me with the consumer side of things, where they say, oh, we've invented a new kind of plastic. Unobtainium. Yes, and it's in our new cables, and they're only $500 per foot. And they're at CES. I'm going to go see them next week, Oh, and they're so exotic. But don't ask what's inside them, because even we don't know. But boy, do they sound
We can tell you
good.
there's no oxygen in there.
Yeah,
Absolutely
no oxygen in their head, maybe. So.
Hey, Steve, I got a question for you. Actually, I want to shift gears a little bit here. At one point, when you came down to SBE 15, we had a discussion about RF.
Yes.
And there was some mention about most RF amplifiers wanting to run around 30 ohms. And, we were talking about how you can easily get RG8 or RG58, which is 50 ohm coaxial cable. You can get RG59, RG6, RG11, which is 75 ohm coaxial cable.
Yep.
But you never see that 30 ohm coax cable.
Nope.
I thought that was just fascinating when you mentioned that.
Well, there's really a very simple reason why. And that is, in a coax, the impedance in a coax, and here's a pretty big coax. This is RG11, the one you were talking about. 75 ohms. I call this the garden hose of digital video. This is so huge, even this, and believe me, we make bigger cables than this. I could pull out some huge cables. The whole point is, this is such a big coax that by the time you get to these kinds of dimensions, you have a hard time even putting something in. And the problem is to get from 75 ohms, this is 75, to 30 ohms, which is what would be ideal for a lot of applications. It's a ratio of the sizes inside the cable, the ratio of the center conductor to the distance to the shield and the plastic in between. Those are the three magic numbers, which, if you think about it, is RLC. It's the same things that was in the twisted pair. And that ratio at 30 ohms is so small, you have a little tiny center conductor and a giant wire around it, giant coax, with a shield around it. And it's very hard to put that little tiny wire in the center of the cable. That's the problem. And so a lot of the time, most of this cable wouldn't be 30 ohms. We'd have to throw it away. It wouldn't meet spec. And in fact, we actually did make some 30 ohms a long time ago when I first joined Belden 20 years ago, back when I was young and foolish, and told them we could do it. And we had to throw 50% of it away. And the interesting thing is, before then, there were times we made 30 ohm coax back in the war. We threw 90% away.
Wow.
So, in fact, we're getting better. I bet if we made some today, we might throw 20% away. That's still a huge amount to throw away of something you're making, of course. You want to throw nothing away. And this is one reason why 30 ohms is just not something that's easily obtained. I mean, if you want to buy some, we'll probably make it, and we'll charge you for the stuff we throw away as well. And suddenly that stops a lot of customers.
Hey, in a few minutes we'll get to Guinness World Record stuff, like what's the biggest and what's the smallest cable that a company like Belden would make.
Yeah.
But I know I'm still back on this bend radius thing, because I know I've made the mistake of putting in cables and if they're just carrying audio, it doesn't much matter if you put a 90-degree bend in it so it'll fit in the back of a rack.
Absolutely.
Just right.
Because you think about
not audio.
The reason that for audio is so forgiving is because at those low frequencies, especially analog audio, impedance doesn't mean anything. Right. What's the impedance of your mic cable? It never says. I mean, your mic might be 150 ohms out. That's different. The cable's not 150 ohms. That cable's probably 30 ohms or some number. We don't even tell you what it is. It's just confusing. And the reason is because it's all about wavelength. You can't go far enough, long enough for it to show up at audio frequencies. By the time you're at video, yeah, the wavelength is like 60 feet. By the time you're at digital video, you can get down to inches, in which case the impedance is very critical. But back in analog audio, it's not critical at all. And therefore, you know, if you bend the cable, if you fold the cable in half, as long as you have continuity, it's going to work. Because it doesn't matter what you've done to the impedance. It's just those frequencies are so low. So all you audio guys, you don't realize what an easy world you have compared to, say, the microwave guys. You talk to a microwave guy, and they'll tell you it's like voodoo. You look at the cable, and it changes, you know? Because their frequencies are way, 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 way high, you know, up in the gigahertz kind of thing.
Okay, so I'm installing some Cat 5 or Cat 6 cable.
All right.
What can I do and what can I not do as far as getting it around a corner or pulling it through something?
Well, it's we go back to the deforming thing. The less it deforms, the better it will work. The rule of thumb, and I could take this to task as well, but the rule of thumb is 10 times the diameter of the cable. Some places will tell you installing 10 times the diameter of the cable, and by the time it is installed, in other words, sitting in place, you can go as tight as 4 times the diameter of the cable. So if you know what the diameter is, you can obviously multiply it by 4 or 10, and make sure you don't get numbers worse than that. Although I'll tell you, I did some tests with coax cables, and if I come to your SBE section, you could ask for my presentation called Bend Radius, where we actually bent coaxes tighter and tighter and tighter. Now this is just coaxes, and it's just our coaxes, it's nobody else's. It's not Cat 5 or anything else. That's a whole nother kettle of fish. But the point is we can bend coaxes much tighter than 10 times the diameter, or 4 or 2 or even 1 times the diameter, and still get pretty good performance out of those cables. Because it's how we build the cables from the inside to resist deformation. And that's the thing. How do you build a cable to resist deformation? Well, you build it in such a way that when you bend it or twist it or something, it has no effect on what's happening inside, on the performance, on the dimensions inside. And that's the thing. People think, wow, how do you do that? Well, we spent 20 years just working on the bubbles in the foam that you put inside a coax cable, which you think, bubbles? We've spent $1 billion on bubbles. Yeah, but it comes out as super high performance and ruggedness and the ability to resist deformation, and you can step on it or bend it in, you know, in a tight circle, and it will still work. That's what you get out of it.
Okay. Say the chat room has been asking a few questions.
Yeah, I can see.
Yeah. And yeah, we all like to know about, you know, biggest, smallest world record stuff. I was wondering, I'll let the other guys ask some other questions, but I want to ask about, sometimes I've had to work with little itty bitty tiny cables, like in microphones or in I guess some in headphones or earbuds and that kind of thing. Does Belden make any of these ridiculously tiny cables?
Not yet. This is one of the things, since I'm the product line manager, you know, you're getting into my bailiwick. I have pushed us to make these cables for the longest time, but at least for the teeny, tiniest cables, because there are lots of things we could do in tiny cables, like, well, now you're going to start me talking theoretically here, copper-clad Kevlar. You've probably never heard of such a thing, but there is such a thing. They use it in satellites for wiring. Now, I guarantee you this stuff ain't cheap. But you want to make a cable that's microscopically tiny and yet strong? Well, you know, we can even do copper-clad steel, which we do for quite a few other things. If we want to make something super strong, I could take a steel wire, put copper around it, and it's not as good as an all-copper wire, but it's a heck of a lot stronger. So there are all sorts of things I could do making microscopic cables if we decided to go in that direction. But I'll tell you, the interesting thing is, you look at the performance, excuse me, of things like earbuds and stuff. Almost none of that performance is really based on the cable.
Yeah.
As long as you get continuity, you're going to get whatever performance you need out of that. If you're talking about mic cables, then you're talking about a twisted pair. That's a little more performance than just lamp cord. We're going back to that, you know. So, you want microscopic lamp cord? Yeah, we could do that. At the other end, of course, you know, you have Andrew and giant coaxes and things like that we don't make. In fact, I pulled out this here. This is the largest coax that Belden makes. This is called RF600. And, you know, in the scheme of things, this is a pretty huge coax. But compared to, you know, what's going up a tower for most broadcasters, this is nothing. Although this cable will do 5 kilowatts at 30 meg. I mean, this is no shrinking little cable. It'll do 300 watts at 6 gig. So, cool cable. Just, this is as big as we go. That's all. So, the Guinness Book wouldn't be calling us anytime soon.
Sounds like Chris Tobin's got a comment or question.
Please.
A question that comes up a lot in installations I've worked on. Here in New York City and probably most large cities, Teflon cable required in plenum space, or plenum cable, I should say, required in open air spaces. How much different, or what do you? I guess in the design does Teflon or the not PVC, but the plenum rated material, does that impact and change the way the characteristics of the cable function, or is it just strictly manufacturing? Because sometimes when I've worked with it, it's like a whole different way of handling it and putting terminations on it and stuff.
Yeah. In fact, I'm glad you were confused when you started that about saying Teflon, PVC. No, I meant plenum, because so many people are confused by this entire thing. Now, here it is in a 30-second synopsis. There are fire ratings. The fire ratings determine the safety of the cable, and by that I mean the intent in the USA by a group called the NEC, National Electrical Code, which is run by a group called the NFPA, the National Fire Protection Association, out of Massachusetts, I believe they are. You can get a copy of the code. It's a book. You can buy it. It's a voluntary book. In other words, it's not the law. It's not the government. But a lot of local places, a lot of local governments subscribe to this book as if it were law. They have adopted it as their law. Now, it talks about the safety of building buildings that won't kill people. And one of the things that has to do in that would be the wiring that goes in the building and the ability of that wire to not burn, or not burn as badly as other wire might burn. And therefore you have different kinds of ratings, like CL2, CL3, CM. These are all different ratings of the flammability of the wire. And really what they're talking about is, where can you use this cable where it doesn't need to be protected otherwise? And by that I mean, most people would assume that means in a conduit. That you can take a cable, put it in a conduit, and it's pretty well protected. But even now, as of 1999, the NEC says any cable that is installed, now you could argue about the word install, but any that's installed must have some kind of rating, even if it's in a conduit. You cannot take an unrated cable, like a microphone cable, for instance, and put it in a conduit. That is not legal in the United States, in the communities that subscribe to the NEC. So the question is, when can you not use a conduit? Well, if you're in a plenum space, which is the highest rating, and you cannot use a conduit and put some rated cable in the conduit, then you have to use a plenum rated cable. Now, how do you make a plenum rated cable? Well, there's a test called the Steiner tunnel test. And if you're really interested, I'd say go Google Steiner tunnel, and you will learn all about how they test cables. And what it is a box, a chamber, with a flame source, and they put a piece of cable in, and they light the flame, and they notice how long it takes to travel down the cable, how long the cable will keep the flame going, and it looks at like smoke and toxic fumes and lots of other things that are associated. Ah, hey, nice. And in Europe, they have a completely different set of tests, so they have completely different cables. Plenum cables mean nothing to them in Europe. They have other requirements. And I always tell people it's just a question of how you want to die, you know? In their case, you want to see the door on the way out, or do you want the toxic fumes to get you before you get there? It's one or the other. Which would you like? And the original way we made plenum cables, which is cables that you really can't see, that's where plenum goes, is in a drop ceiling or a raised floor in a commercial building. This isn't in your home. They don't care if you die in your home, but if you die in somebody's business, that's a big deal. And so you want a plenum-rated cable where you cannot see it, where it's not visible in a plenum. Plenum is an airspace, by the way, of part of the air conditioning system. And the point is, the first material that was available was Teflon that could meet these specifications. Now, Teflon is owned, lock, stock, and barrel, by DuPont. They own Teflon. Belden happens to be the world's largest user of Teflon. Thank you very much. Which means DuPont is one of our closest and dearest friends, as you can imagine, because we're their #1 customer. But along the way, we realized we could produce other kinds of materials, other kinds of plastics that don't require Teflon that could meet the spec. Some of which are PVCs, polyvinyl chlorides, that are specially made so they won't burn either. They'll meet this Steiner tunnel test. And a lot of cables, for instance, you'll see, if we make a plenum video cable, for instance, it'll have this PVC on the outside, something we call flame arrest, but other manufacturers have names for it, you know, as a special plenum-rated PVC. But the inside is probably Teflon, because you need the performance inside, and PVC just doesn't give you the performance. So if it's a speaker cable, it might be all flame-rated PVC on the outside. Nobody cares about what's on the inside. If it's a video cable or something exotic, you know, then you'll have Teflon inside and PVC on the outside. If you want something that you can run through a blast furnace and would work, it might have Teflon on the inside and Teflon on the outside, which we also make. You want to spend money? That's a great way to spend money. Just ask for Teflon inside and outside, and yeah, we'll guarantee you we'll spend a lot of money, and we'll give a lot of it to DuPont. That answer the question?
I think so. Steve, I think we could carry on this conversation for a long time, and unfortunately we don't have a long time. We had an hour.
Now you tell me. Yeah. I thought that was just the opening.
Opening act. Steve, I hope you'll come back and
no,
talk
I'm
to
sorry.
us more
no,
sometime.
I can't. I don't come back. No, that's it. Sorry.
Can you talk to us about optical cables next time?
Oh, light?
Yeah,
there is such
light.
a thing?
Yeah.
Yeah, sure. We could do this.
That'd be interesting too.
Yeah.
This has just been fascinating. We got to get you.
Nobody
over
mentioned
to
wireless. I mean, I was prepared to talk about wireless for the whole show.
Belden wireless cables.
Yeah, wireless is very interesting stuff. You think I'm joking, but in fact, we have a trademark. We are the wire in wireless. Oh yeah.
Interesting. If people need to reach you, Steve, where can they reach you?
Very simple. Steve.Lampen, Lampen, at Belden, BELDEN.com.
Good deal.
How easy is that?
That is awesome. I have learned so much, and you're a great storyteller. I know you hear that all the time, but it is so true. We'd love to have you back.
My pleasure. Thanks for having me.
In the SBE chapter or trade group that deals with wire, I think you'd be very lucky to get Steve to come talk to your group.
Anytime.
Oh, it'd be it's very good. I've enjoyed many of his talks. Trust me, it's worth it. Any member out there, have him come in and talk.
Yeah, I'll be at the end of January, whatever it is. I don't have the date here in my brain, in St. Louis, Chapter 55. I'll be there.
All right. A short drive from much of mid-America.
Yeah.
Steve, thanks again for being with us. I also want to thank the co-host, our co-host for being with us from New York City, Chris Tobin. Chris, thanks for joining us this evening.
Oh, you're welcome, and thanks, Steve, for joining us and giving us a lot of good stuff every time.
Pleasure.
Just a short way up the road, Tom Ray from his ham shack. Thank you for joining us, Tom. I appreciate you.
Hey, he's muted his mic again.
He's muted again.
I love it. like I was saying before I was, again, so rudely interrupted by my muted microphone. Appreciate being here, as always, and always appreciate having Steve Lampen on and listening to what he has to say, because, quite frankly, it's informative and a lot of fun.
Sure is. And from Muckwonago, Wisconsin, a guy who's about to put a bunch of Belden cable in and not twist it too tightly. Chris Tarr, thanks for being with us.
Thanks for having me, and thanks, Steve, for a great presentation. Enjoyed it a lot.
My pleasure, absolutely.
All right, guys. Our show has been brought to you by Omnia Audio at omniaaudio.com. And if you would please record a little video of yourself and your Omnia processor and send us a link to it, whether you put it on YouTube or a private place where you can store the file. Let us know about it. Send information about that to D. Sanders at omniaaudio.com. That's Denny Sanders, my colleague at Omnia, D. Sanders at omniaaudio.com. Well, right there's a video right there. Yeah, look at that. Send us a video. Tell us a little bit about it. There's some Italian going on there along with the Omnia processor. Yeah, tell us what you like or what you think we should do different. That'd be, there's the back of it. The Ethernet cable going in there and some, look at that.
Is that tell us what you'd like?
Sorry?
Tell us what you'd like, right?
Tell us. Gee. He'll be here all week, folks. Try the beef tips. Steve Lampen, thanks again. All right, folks, you've been watching This Week in Radio Tech. Next week, we are taking one more week of hiatus. We're on a short vacation while the TWiRT Network gives you wall-to-wall coverage of the CES show, the International CES in Las Vegas. So we'll see you in a couple of weeks with episode number 112, and we'll look forward to seeing you then. Thanks for watching us. We'll see you next time on This Week in Radio Tech. Bye-bye.